Hello everyone, my name is Hüseyin AKSÖZ and now I will demonstrate my Analog CMOS integrated circuits course project. So this is the symbol of my op-amp chip. As you have seen, there are four outputs for each op-amp and corresponding inputs for these op-amps. Inside of this chip, here you see the schematic of the four op-amp concept. There are four individual op-amp symbols and a bias symbol for driving these op-amps. There are four outputs and one each for each op-amp and two inputs for each op-amp. Inside of, for example, this block, here is the op-amp circuit, the schematic of the circuit. There are 7 transistors. There are 4 PMOS and 3 NMOS transistors in this schematic. There is an output of Vout and 3 inputs which are V bias, V input minus and V input plus, and I drive this op-amp here using a VDD line. Here you see the separate bias circuit. It consists of a PMOS transistor and a resistor, and it also has a bias output. And here I have designed the layout of a single op-amp chip. It consists of all the components you have seen in the schematic for an individual op-amp. You can also see the routes driven by myself and by doing auto-routing. I have some parts aren't drawn by the auto-routing of Cadence, so I have drawn them by hand. And I have also adjusted the number of gates of transistors to have square-shaped transistor for ease of easily putting them inside the layout. So this is the layout for my bias circuit. Here again you can see the components and the paths. And I have, after making these designs, I have combined them here. There are 4 individual layouts for the op-amps and the bias layout for the bias circuit. And you can see the paths which connect these separate layouts together. After completing my design, I have tested it. Here you see the test circuit I used for measuring the phase margin and testing the circuit for stability. And I have also measured my circuit's bandwidth in unity gain configuration, and this is the circuit I've used for this purpose. Thank you for listening.